Right, let's look at this question. Let's apply completing the square for this on these functions. Look at the coefficients of x squared. The coefficients of x squared currently it's 2, right? So before we can apply the steps to complete the square, we have to make coefficients of x squared to be 1. Hence, we need to factorize 2 out. All right, then the next step is that after having done that, right, we will have to examine, look at x squared minus 5 over 2x. Look at the coefficients of x, which is currently negative 5 over 2. Take negative 5 over 2 divided by 2. This one you can easily use a calculator to work it out, and that will give you negative 5 over 4. Right, so the next step is introduce a square bracket plus negative 5 over 4 square root. Okay, remember that you see this is what you're given is an expression. So if you're given an expression, you can't simply just add something. If you just add something, the expression means you're changing the question. Is that, for example, if you're dealing with a number 3, if you just simply add 2, then it becomes 5, which is not correct, right? So to continue to make it remain as 3, if you add 2, then you have to take away 2. So likewise, if you add negative 5 over 4 squared, then we will have to take it away. All right, your 6 still remain there. Okay, so what happened now is this guy here, right, will remind you of your a squared minus 2ab plus b squared. And you can just collapse it into x minus 5 over 4 square root. All right, and we still have to work this out, where you can just simply use a calculator to work it out. To gives you, just use a calculator to work this out first. Make sure you bracket negative 5 over 4 square, close the bracket squared. Use a calculator correctly, you will give 25 over 16. Okay, we're not done yet. We still have to multiply the coefficients into the huge square bracket. And that will give you 2 minus 2 multiplied by 25 over 16 plus 6. Okay, so the next step is pretty easy already. Next step, you can just simply use a calculator to work this out. Oh, I don't have a calculator here. Wait, let me try to work it out manually. Okay, that will give you positive 23 over 8. Right, so this is how you can apply completing the square method to complete these functions. All right, if you do not wish to use this method, okay, that's another way of doing it. All right, another way of doing it is, okay, we're going to branch it out from here. So this is the alternative method. Now, so we understand that if you were to complete the square for the function, you will end up in this format. Okay, but your h and k are constants. Right, so once we know that, what you can do is that we know that it will be something squared. Right, something squared here, then minus something. And of course with the plus 6. So how do we do it? So we know that it will be just the steps is the same. You take the coefficients of x divided by 2, that gives you negative 5 over 4. So it will be bracket x minus 5 over 4 close bracket squared. And I need to take away something. So the one that I'm taking away is the square of this guy. So the square of the guy is 25 over 16. Okay, so we can also do it this way. And if you use a calculator to work this out, you will end up getting 23 over 8, which is the same answer as what I've done earlier, using the tradition method. Oh, not the tradition, I should not say that, using the method that is been explained in most of the textbooks. Right, let's do another questions. Let's examine the coefficients of x squared first. The coefficients of x squared is negative 3. Right, so we have to make the coefficients of x squared to be 1. So we need to factorize negative 3 out first. Right, do you know why this sign here has become a positive? I leave this to you to go and think about it. Huh? Okay, so the next step is I need to complete the square for this. Right, so what is it that I need to do? I need to add something, right? I need to add the coefficients of x, the square of the coefficients of x divided by 2. So the coefficients of x right now is 5 over 3. So we need to take 5 over 3 divided by 2. We use a calculator to work this out. That will give you 5 over 6. Right, so I need to add the square. And then I need to, in order not to change the question, you add it, you have to take it away. All right, so this will collapse it. This will remind you of your a squared plus 2ab plus b squared. So it will collapse it into x plus 5 over 6 squared. Right, in this one here, if you use your calculator, it will give you 25 over 36. All right, so we are not done yet. The next step is to multiply the negative 3 into the square bracket. In this, you can just use your calculator to help you evaluate it. And that will give you negative 59 over 12. All right, let's do the other method. So the other method, okay, we understand that after completing it, it will be in this format. All right, so we know that starting from here, okay, the factorization is the same for whichever method you use. So you have to factorize, you have to make the coefficients of x squared be 1 first, okay, before any of this method. So here we understand that it will be x plus, okay, why plus? Because the coefficients of x here is a positive 5 over 3. The coefficients of x is a positive 5 over 3, so it's plus. So 5 over 3 divided by 2 will be 5 over 6. So plus 5 over 6. Then we square it. Then we must take away, right? Take away the square of 5 over 6, which is 25 over 36. Then minus 7. Okay, then we continue. So you multiply the negative 7 into your square bracket. And this, we can just use a calculator to work this out. You get the same answer as what we have done earlier, which is negative 59 over 12. Okay, so here we are, two different methods. You see which methods you are comfortable with. Right, so we have done the completed form for these functions 2x squared minus 5x plus 6. So what can we say about what kind of information can we derive from this completed form? Okay, so first of all, we're going to find your fx intercept value. If you remember, if you were to replace fx with the letter y, then we're actually finding the y-intercept value. So to find the y-intercept value means we let x equals to 0. So when you substitute x equals to 0, I have f of 0 equals to 6. So 6 is your f of x intercept value. Right. And then let's look at other information. So for all real values of x, that means I can substitute my x to be any values. For all real values of x, meaning x can take in any values. Positive, negative, integers, rational, irrational, real numbers, whatever. Right, so you observe that when you square x minus 5 over 4, right, the minimum value is 0. It can be anything more than or equals to 0. So hence the minimum value of, okay, so if the minimum value of x, square of x minus 5 over 4 is 0, if you multiply it with the 2, the minimum value is still 0. And so therefore, the minimum value of your f of x will be 23 over 8. That means if you were to replace your f of x with y, the minimum value of y, the smallest value of y will be 23 over 8. And we want to find the corresponding values of x. So the corresponding of values of x is when we let this one equals to 0. Okay, because the minimum value to get 23 over 8, it's when I let this value here that I put the red arrow equals to 0. And solving it, you get x equals to 5 over 4. So in other words, when I substitute my x equals to 5 over 4 here, right, when I substitute x to be 5 over 4, I will have 5 over 4 minus 5 over 4, and you square it. So 5 over 4 minus 5 over 4 will give you 0. You square 0, you get 0. So the minimum value is 0. So 0 plus 23 over 8 will give you minimum value of fx to be 23 over 8. This is what it means. So from there, we can conclude that the minimum point, right, the x coordinates of the minimum point will be 5 over 4. And then the fx coordinates will be 23 over 8. So if you sketch the curve, it will look like this. Right, so let's look at these functions. So earlier on, we have already completed apply the steps to complete the square for these functions. Right, so we have already done the completed form. Right, so what are the informations that we can gather here? All right, so for all real values of x, what can we say about the square of x plus 5 over 6? Right, it will always be positive, right? And what can we say if we're going to multiply it with a negative 3? Will it still be always positive? No, right? A positive number, if you multiply with a negative, will give you a negative. So in this case here, your negative 3 bracket x plus 5 over 6 bracket squared will become less than or equal to 0. So therefore, the maximum value of negative 3 is 0. Right, the maximum value of that will be 0. And hence, the maximum value of f of x would then be 0 minus 59 over 12 gives you negative 59 over 12. All right, so we have already, so to make it happen, we need to find the x coordinate. We already got the maximum value of your f of x, that refers to your f of x value. So now we have to find the corresponding x value. So that happens when we let equals to 0. So solving it, you get x equals to negative 5 over 6. So therefore, the maximum value, or the maximum point of this function would be negative 5 over 6, negative 59 over 12. So how would it look like if you were to sketch the curve? So if you were to sketch the curve, this will be how it looks like. Oh, and we still have to find your fx value. So to find your fx-intercept value, that is when you let x equals to 0, right? So when you let x equals to 0, let's see what happens. You can actually substitute into this form, the original form. It's easier rather than substitute into your completed form. Right, and you get negative 7. So negative 7 is the f of x value. So negative 7 will be somewhere here. So if you were to sketch your curve will look this way. Right, where your maximum point, this will be your maximum point here. Right, so from the past few examples we have done, if you're given a completed form, right, will you be able to write down the maximum or minimum value of fx and the corresponding values of x? Will you be able to write down the maximum minimum point? Okay, let's do one example. For example, if you have this expression, a quadratic function, f of x equals to, let's say have already expressed it in a completed form. Right. So will you be able, from the completed form, write down the maximum or minimum point? So will this curve have maximum or minimum point? Yes, this curve will have a minimum point. And the minimum point will be, right, if you let this equals to 0, then your x coordinate will be 2/3, and your fx value will be, the minimum value will be 4. So that will give you the minimum point. So from here, we can also conclude that f of x, for all real values of x, f of x will always be greater or equal to 4. Okay, so if you were to sketch the curve, this will be how it looks like. Okay, let's do another example. Let's say if you have this, what do you think? Would this curve have a maximum or minimum point? Yes, this curve will have a maximum point, which is equals to -4, -7. How do you get -4? That is when you let this equals to 0. Solve it, get x equals to -4. Right. So for all real values of x, your f of x will be less than or equal than -7. So if you were to sketch the curve, how do you think it will look like?